The next piece that we're looking at is then a GCF. Right, so my students tell me all the time as soon as I say GCF, right? Greatest common factor. I don't know why, but this seems to be a one way that our brain works. I say GCF, my students all tell me greatest common factor. Instructions say find the greatest common factor, and students raise their hand and say, Mrs. McKinney, you never taught me this. Okay, so be prepared to see it both ways, right? If you read the words greatest common factor, your brain should still think GCF. Okay, great, so we know those words. What is a greatest common factor? What does the word greatest mean?
Biggest.
The largest. What does common mean?
Shared.
Shared, something that they share. What's a factor? Something that it's divisible by. So we are looking for the largest number that a set of numbers can be divided by evenly, right, without getting a fraction. Sometimes when we're looking for a GCF is simple to find. Okay, and if I write down something like 4 and 12, and I say, okay, let's find the greatest common factor. Let's find the largest number that will divide evenly into 4 and 12. What will we probably all say? 4. Why do we say 4? Well, we just know it's 4. Sort of like at this point in your life, if I say y is 2 plus 3, 5, you don't go, well, I took 2 blocks, and then I took 3 blocks, and then I put them together and I counted 5 blocks. Right? 2 plus 3 is 5 because it's just 5. It has been for forever. You really don't even have to think about it. Okay, the same thing is happening here. We know that our GCF is 4 because we know the multiples well enough to know what they're divisible by. However, that doesn't really work as soon as the numbers get larger. So here are the choices today. I can either throw a bunch of really obnoxious large numbers at you and force you to do what I'm about to teach you, or we're going to start with some simpler numbers and we're just going to pretend like we can't just see the GCF. Sound like a better deal? Okay, so we're going to pretend. We're going to do some larger ones too, but. And actually, some of these my students wouldn't even get right to start with. So right, that's exactly the thing. My students will see 24 and 36 and go, oh, it has a GCF of 6.
Wait,
No. That's
Okay, so here's the deal. We need to make sure when we are finding the GCF, we are actually finding the largest number. Okay, so here's how we're going to check and make sure we're finding the largest number. We are going to say, let's pretend that we're all agreeing that we see 6, which is what several of us saw to start with. Okay, so we're going to divide this by whatever number we see will go into both of them. It does not have to be the largest. So I might divide by 6, Justin might divide by 2, Christian might divide by 3, right? It doesn't matter. We could all be dividing by a different number as long as it's mathematically correct. Remember when we were dividing polynomials in first trimester, when we had a large division bar like this, we had to divide both of them? Okay, so 24 divided by 6 is
4.
36 divided by 6 is
6.
Then we're going to do this again. We're going to do the same process. What will go into 4 that will also go into 6? 2. So we're going to divide again. Justin, that's going to make me crazy. Okay, so we're going to divide them both. 4 divided by 2 is 2. 6 divided by 2 is
3.
Again, you could use your calculator to divide if it's larger numbers or if you just want to use your calculator anyways. Then we're going to ask ourselves again, what will go into 2 that will also go into 3? Yeah, nothing is actually 1, right? There really is a GCF of 1 here. I understand why we say nothing because it's pointless to write down 1, but really do need to understand it's 1. That's going to be important later. Once you get to saying there's nothing that we could pull out here other than 1, you're going to stop dividing. And then to find the actual GCF, you are going to multiply everything that you divided by. Okay, so 6 times 2 is 12. So our GCF will equal 12. So let's say we now want to find the GCF of 108, 180, and 72. So we have 3 numbers. We want to find the largest number that will divide evenly into all 3 of them.
Couldn't we add them?
So what do we know that these will all be divisible by?
2.
2. So let's pick 2. Okay, so 108 divided by 2 gives us 54. $180 divided by 2 is 90. 72 divided by 2 is 36. What will divide into all of these? 6. I just heard 6. That doesn't mean you can't pick something else. Okay, 54 divided by 6 is 9. 90 divided by 6 is 15. 36 divided by 6 is 6.
3 goes in these.
And now we can do 3. 9 divided by 3 is 3. 15 divided by 3 is 5.
And 2.
Now it's 1, so we know we don't need to go any further. So we're going to multiply 2 times 6 times 3. So our GCF is going to be 36.
Couldn't we just add all 3 of them up, get 360, and then divide? No, that won't work.
And I'll show you even particular. Right, Bailey? Can't add here. So now we have variables to deal with, but that's okay. Okay, so just like when we are prime factoring, if we have variables to deal with and we're finding a GCF, we're going to deal with the big number. What's the big number called? The coefficient, right? We're going to deal with the coefficient first. So if we deal with the coefficient first, so we're going to ask ourselves what goes into 12 that will also go into 4. 4. Now, before we divide it out, we're then going to look at the variables. We're going to ask ourselves, do they both have an x?
Yes.
Yes. You are always going to use the smallest exponent. Because if we were to prime factor it, right, this has 2 of them, and this has 5 of them. So how many do they both have in common?
7.
2. We're not adding how many they have together. We're adding how many they have in common. This one has 2, and this one has 2. This one just also happens to have 3 more.
Okay.
Okay, so you're always going to use the smaller exponent. As long as they both have it, you're going to use the smaller exponent. So you're going to look at both of the x's and decide which one's smaller. So is 2 smaller or is 5 smaller? 2. And we should be able to divide these because we talked about how to divide with polynomials last trimester. Right, so 12 divided by 4 is 3. And when we divide with exponents, what do? Subtract. So 2 minus 2 is 0. They're gone. Right, no x left there.
3, 8.
4 divided by 4 is 1. Then we subtract exponents. 5 minus 2 is 3. As long as you did your variables right the first time around, you won't ever have to deal with them again. Okay, so we can't go any farther. Nothing else here. So our GCF would be 4x squared. I know today's sort of a big note day. Everything goes downhill after today. Once we have our solid base here, we're good to go note-wise for the rest of the week pretty much. Okay, we okay here? One more. X squared, y to the third, and 21 x to the fifth, y to the second, z.
I feel like these could.
Okay, so we're going to look at the coefficients first. What goes into 14 that will also go into 21? 7. Then we're going to look at the variables. Do they both have an x? Yes. What's the smaller exponent?
The 2.
2, so this will be an x squared.
Y squared.
Okay, so then we'll look at the y's. Do they both have a y?
Yes.
Yes. What's the smaller exponent?
Y squared.
Y squared.
And then Z.
Do they both have a z?
No.
No. So can we write down a z?
No.
No. Okay, so we'll divide this out. 14 divided by 7 is
2.
2. 2 minus 2 is
0.
gone. 3 minus 2 is
1.
1.
So 2 divided.
21 divided by 7 is
3.
3. 5 minus 2 is
Negative 3.
positive 3.
Wait.
2 minus 2 is gone. And the z is just left. Right, that's from dividing our polynomials last trimester. So again, as long as we did our variables right, we don't need to deal with the variables again. So what goes into 2 that will also go into 3? 1, which means we're done.
Which means
So our GCF is 7x squared y squared.